your classmates, okay? So we're going to be swapping places, but I'm going to introduce 2 things so you know what you're doing first. Sound good? Alright, so this lesson we're looking at the trig functions. We have the graph of sine, we have the graph of cosine, we have the graph of tan. The investigations we're going to go through are pretty much for sine, and then I'm going to throw it back at you guys, and you're going to investigate the graph of cosine and tan, and then teach it to one another. Okay, it's part of your homework assignment anyway, so you have to do it anyway. But before we can do that, we have to know a few key terms. So first of all, periodic function. Who wants to read that out? You're going to have to talk in front of your peers today, so you might as well get warmed up. Thanks, Bruce.
A periodic function is a function whose graph repeats regularly over some interval of the domain. The length of this interval is called the period of the function.
Awesome. Okay, and we determine the period by seeing a pattern in that function and where it starts and where it stops and then where it starts again. So if we were to look at this first example, okay, it starts along or at the origin, okay, and then it goes up and then it goes down. Did the pattern start again? No. Not yet. Okay, keep going down and then back up. Now has it started again? Yes. So we could say that the period goes all the way till we get to 8 on the x-axis. So the period has a length of 8 units. And I recommend that you always, if you can, start at the y-axis. Okay, because at the y-axis, x is 0, and then you just count to where it ends. Okay, you don't have to do any additional math. Amplitude of a periodic function is defined as half the distance between the maximum and the minimum. So in this case, our maximum is at 10, our minimum is at negative 10. So what's the total distance from max to min? 20, so what's half of that? 10. That's your amplitude. Okay, and the way you're going to calculate it will always be your max, subtract your min, divided by 2. So in this specific example, we have 10 minus negative 10 divided by 2, and we get 10 units. So let's check out the next example, B. Okay, do you think I should start before the y-axis? No. Let's start on the y-axis. Okay, tell me when to stop. When does the period stop, the first period?
No.
Keep going.
Stop?
No.
I feel like this is like, have you seen The Price is Right?
Oh yeah.
And they tell you where to stop.
Oh yeah.
Okay, tell me when to stop.
No.
Stop.
No. A little more. Right there, yeah.
Okay.
Yeah.
Alright, so we're going to stop there because if I were to repeat that, I would get the same pattern. Okay, so the period length is just showing the trend of the graph, okay, and what trend is going to be repeating over and over and over again. So the period of this goes from 0 to 6. So the period is 6. Okay, amplitude, we have to go maximum, subtract the minimum, divided by 2. Here the maximum is at 6. We're going to subtract the minimum at negative 2. Divide by 2. We get 8 divided by 2 is 4. Okay, I need a volunteer for the last one. Xander, you asked me to keep you engaged, so I'm going to bring you up. Come on up. Okay, we're going to help Xander find the period of this. Ready? So let's help Xander out. Where should he start?
Why?
On the y-axis? Okay. Yeah, good. Okay, now follow the graph and tell him when to stop.
Well, stop.
Yes.
We went too far.
No, we went too
Well,
far.
like
You want to start
yeah,
on
you
the
went.
y-axis.
Erase that a little
Erase
bit.
the,
So
like, 10 to 15.
Go to 10. Go to 10. No.
Yeah.
Right there.
Is that better?
Yeah.
Okay. So a few questions from the audience. Oh, sorry, carry on. So let's just write down the period then. The period goes from 0 to 10. Very good. It wouldn't matter because it would end at the same spot. So I got a question from the audience. Xander, you did a wonderful job. Good job. So the question was, well, do we start down here or do we start up here? And really it doesn't matter because it's along the same line. So, sorry, I'm going to erase your work, Xander, but you did a very good job. So what if I start up here? Okay, I got to go down, over, up, and across. And then I would stop before it repeats again. Where is it ending? At 10. So your period is 10. Pardon? Oh, I thought you were saying. Okay, and then the amplitude? That's going to be your max minus your min. What's the distance between 6 and 2? 4. And then half of that? 2. Okay, so 6 minus 2 divided by 2 is 2. Okay, it's always half the distance between the max and the min. So as I mentioned at the beginning of the class, the graphs we're going to explore in this lesson and assignment are the graph of sine, the graph of cosine, and the graph of tan. And we're going to be exploring the period as well as the amplitude of all three. And like we've been doing so far in the year, we've been also talking about domain, range, and the x and y intercepts. So we're going to have a little explore. Yeah. Alright, the first graph we're going to look at is the graph of sine. And in this case, x is in degrees. So what you want to do first of all is just make sure your calculator is in degree mode. We've been dealing with the unit circle, so if you want to continue practicing it, you can use your unit circle or special triangles. For example, sine 0 degrees. Okay, sine stands for what letter, x or y? Y. And the y value at 0 degrees is 0. So I could use my unit circle to figure that out. Or if I'm in degree mode, I could go sine 0 degrees, enter, and you'll get 0. Now, one thing that's, I guess if we want to be more time efficient here, give your answers to the nearest 2 decimal places. Do I care about the exact value? Do I need square root of 3 over 2? No, I just need decimals. So for the rest of this, we're just going to use our calculator. Sine 30 degrees. 0.50, so we need 2 decimal places. Doesn't make much of a difference, but it doesn't matter. Okay, sine 60 degrees. 0.866. 90 degrees.
1.
Very good. 120. 0.866. Okay, sine 150. 0.5. And 180. 0. Okay, let's just graph these. We'll plot these for now. So when x is 0 degrees, we're here. Okay, and our y coordinate is sine 0, which was 0. So we're just at the origin. That's our first point. Now before we can plot any of these points, we need to figure out what is the scale of our graph. Okay, what are we going up by here? Sorry, on the y-axis. 0.2. Okay, 2, 4, 6, 8, or 1. Okay, and if we take a look, we have 3 spaces going to 90. So 90 divided by 3 spaces is 30. So each one of these ticks represents 30 degrees. Okay. So now that we know our scale, we can go ahead and draw 30 degrees, which will be our first x scale. will be 0.5. So we're going to count that 0.2, 0.4, and then halfway. Okay, at 60 degrees, we're at 0.866. So we're going to go 60 degrees, or at 0.8, close to 0.9, not quite. Okay, at 90 degrees, we're at 1. And then it's symmetrical, so you can just kind of match up the points that you had, moving over 1 unit on your x-axis. Now that's actually only half the period of the sine graph. Okay, we've only gone from 0 to 180. Let's figure out what the other half's going to do. So sine 210. First of all, I want you to think about what quadrant you're in at 210 degrees. What quadrant? 3.
3.
Yeah, 3. Okay. And sorry, I was thinking 2 for a second, but you're right. Yeah, it's 3. Okay, so if we're in quadrant 3, what is the y value going to be? Negative. Okay, we're in this quadrant here. Y is going to be negative. So if x is at 210 degrees, y will be negative. So right away, we know it's going to be a negative value. Okay, what is sine 210? That's decimal. 0.5? Okay. Okay, sine 240? Okay, 270? -1, and then we're symmetrical, right? And back at 0. So now we can plot these points. So at 210, we're at negative 0.5. At 240, we're at negative, oops, I went a little too close. Okay, 245, there we go. Okay, sorry, at sine 240, we're at negative 0.866, so we'll be about here. Okay, and then at 270, we're at negative 1, and then we just reverse until we're back at the x-axis. So I know the question says do not join the points, but I just want to show you how the sinusoidal graph works, or the graph of sine. Okay, that would be 1 period of sine. Okay, and the reason why I'm connecting the dots is because can we not calculate sine 2 degrees, sine 38 degrees, sine 67 degrees? We can go and calculate all those degrees in between, which means these would be connected. Okay, so this is 1 period. Now what I want you guys to do is you're just going to investigate, well, what does sine look like on your calculator? Just make sure I line that up again. Okay, do you guys think that this is just going to be this graph and then it stops? You wouldn't know probably, so let's just test it. First of all, if we're dealing with degrees, we need to make sure that we are in degree mode. So go to mode, over to degrees, press enter. Then there's some suggested window settings down below. On our x-axis, we need to go from negative 360 degrees up to positive 540 degrees. And our scale, just like on the graph, is 30 degrees. On the y-axis, we're going from negative 1.2 to positive 1.2. And just like on our graph, our scale is 0.2. Now before you hit graph, we need to put the graph in there. Let's put sine x. We're going to graph that. Fancy. So you're seeing that it's going on and on and on and on. And if I made my x-axis to infinity, it would just keep going. And if I made my x-axis to negative infinity, it would keep going in this direction. Okay, so you can see it's like a wave. So at the bottom of our page, it's asking about a a few specific things. So just looking at this graph, if we were to talk about the domain, and I'm just going to get you guys to fill in the blank at the bottom. Okay, what would be the domain of this if this just kept going? Okay, good. So our domain is element of all real numbers. What is the maximum and the minimum for our y values? Good. Max is 1, min is -1, so our range will go between -1 and +1. Okay, what is the period of a sine graph? 360 degrees, good. If we're talking about degrees, we'll describe it in degrees, but if we're in radians, someone said 2 pi, you're correct. Okay, so we're going from 0 to 360 degrees. So the period will be 360 degrees. What's the amplitude? 1 minus -1 over 2. 1. Okay? From 1 to 0, it's 1 unit. And then down to -1, that's another unit. So half of 2 is 1. A little trick, if you ever have a graph that is symmetrical about the x-axis, you just have to look at what is the maximum. Well, it's 1 unit. That's half of the total distance, okay? Where are x-intercepts? Where are we finding those? Good, we have 0, 180, 360. 0 degrees, 180 degrees, 360 degrees. Where would be the next x-intercept? Any guesses? 540. Good. Okay, so we're taking 360 plus another 180. So every 180 degrees, you're going to have an x-intercept for the sine graph. Okay, where's our y-intercept? 0. Okay, so it's important to know that for the sine graph, we start at the origin. Okay, that's where we can start seeing the pattern. Unless we get into transformations, then it might not start there. Okay, but the base graph of sine x will start at the origin. So what if I wanted to graph this in radian mode? What would I have to change? Maybe we'll just try it. Okay, let's change our mode to radian. And if I graph it, let's see what happens. That's crazy. So what do I have to change? So that's not the graph of sine.
No.
Yay, good job. Okay, so on the next page it's asking you about window settings. Okay, let's just flip forward here. So I just changed it to radian mode, but the reason why I'm not getting this graph of sine is because my window settings are off. So if I'm in radian mode, what is 360 degrees? 2 pi, but remember it will be -2 pi. So let's go -2 pi. And as soon as I arrow down, it's going to change it to the decimal, the radian decimal, okay? So you don't see the pi anymore, but that's just the value of it. Okay, 540, how many pi's? 360 plus 180? 3 pi, good. Okay, because 360 is 2 pi, plus another pi, that's 3 pi's. Okay, and our scale is 30 degrees in radians. You guys should know this from the unit circle.
3 pi divided by 2, or 3 squared pi over 2.
Good, pi over 6.
That was close.
Just where were you saying? So pi divided by 6. Okay, and do I need to change my y scale? Is the y scale in degrees? No. So we're okay on the y scale. Now let's graph it and see if we're happy again. There we are. Okay, so for part A, if you guys just want to copy down what you put in your window settings. And if you want, you don't have to write these decimals. Obviously, you're going to write 2 pi, and 3 pi, and pi over 6, okay? And let's just practice. So you guys don't have a scale, but what I want you to do in part B is just draw the graph of sine. And as we do that, we're going to talk about some of the features again. So first of all, the domain 0 to 2 pi would look like this. We don't have any negatives. Okay, this is the domain that we're looking at. 0 to 2 pi. So where does the graph of sine start?
0.
Okay, at the origin. And where's the significant point? If I'm going to start drawing this, what would this be at?
1.
Okay, maximum of 1, and where would it cross? Pardon?
90.
90 degrees? Yep. Okay, because where is it going through the x-axis? And I'll make this a little bigger, my scale isn't accurate. Okay, do you guys remember the x-axis? Okay, 0. What's the next one? 180. And then 2 pi. Every 180 degrees, you're going to have an x-intercept. Okay, so here we have pi and 2 pi. Now some significant points are our maximum, where y is at 1, x is at pi over 2. Okay, and then our minimum is at y is -1, and we're at 3 pi over 2, or 270 degrees.